Welcome to Ask and Learn.
Would be to convert the initial velocity from kilometers per hour to miles per hour, and so, to meters per second, right? So you multiply this by 1,000 to convert that to meters, and then you multiply 120 by 120,000 by 1 over 3,600. That's because it's 1 hour and 3,600 seconds that makes 1 hour. And so what you get is 33.33 meters per second for the initial velocity. Now, we want the volume of air that is brought to rest in 1 second, okay? Because, well, let's just find the volume of air. So we're given 2 dimensions. We have 45 meters and we have 65 meters, and we'll multiply 33.33 meters there to that, because that is the because that will be the length for which the wind acts on the building in 1 second. So this is the volume of air required to bring. This is the volume of air required to, or volume of air that will be brought to rest in 1 second. Okay, V is, in this case, is big V. It's different from this small v here. This is velocity. This is volume. Okay, there's a difference there. And then we use Newton's formula, which is force equals rate of change of momentum. So force equals mass times change in velocity over change in time. Change in velocity, so delta V over delta T. And mass is, so mass over volume is density, as we recall. So mass is actually density, which is given by rho, times volume, big V. So you substitute that here. So this is rho big V times delta small v over delta T, okay? And so rho is given, the density of air, 1.3 kilograms per meter cubed, times this volume. It's 45 by 65 by 33.33 meters cubed. And to this, we multiply the change in velocity, and that will be 33.33 meters per second minus 0, because you're bringing it to rest. Divide that by 1 second, because this is for 1 second. And what you get out of it is 4.2 times 10 to the 6 newtons. And that's it.